The need to diversify Europe's natural gas supplies using the Caspian Sea reserves has led to the opening of a new corridor to ensure their transport from Bulgaria to Austria. BRUA is a project through which a new gas pipeline will be built, pipeline that will connect the technological node at Podișor with Horia gas metering station on the route Podișor-Corbu-Hureșani-Hațeg-Recaș-Horia. The project is intended for the construction of a 32-inch DN800 pipe on 479 km length and 3 stations at Podișor, Bibești and Jupa, each of them equipped with 2 compressing aggregates and the possibility of providing a bidirectional flow of gas. For pipeline execution, the distance was split into 3 lots, with Habau PPS pipeline systems being the association leader for Lot 2 and 3. Lot 2 consists in a pipeline with a length of 140 km and the construction of a gas compressor station in Bibești along its route. The pipeline for Lot 3 will measure 159 km, also including the construction of a gas compressor station along its route in Jupa. On this trace, 3,394 DN800 hot bands will be installed and 9 horizontal directional drillings with a length of 4,721 meters will be executed. The pipe to be installed in Lot 2 leaves from the plateau area, then crosses the National Park Valley of Jiu River, whose maximum altitude exceeds 1,600 meters. It was declared a protected area in 2005 and it's a mountainous area with rocks, slopes, peaks, mountain meadows and forests. The route of the pipeline follows the road that crosses the park, descending to the Hureșani subhill area from where the assembly of the pipe for this lot will. Once the site handover is finalized, the first field operations begin. The route established by topo measurements is marked properly in order to begin the topsoil removal. The working corridor is picked at a distance of every 15 meters and marked with a warning strip. The current width of the working strip is of 21 meters for agricultural areas, while it is restricted to only 14 meters in the case of the forest areas, fruit gardens and vineyards. The 30 cm thick layer for the plant is removed on a width of 16 meters and it's stored separately from the rest of the excavated soil in order to restore the site affected by the works. The pipes are transported from the storage unit directly along the working strip, being strung along the route and prepared for welding, being insulated against corrosion. The DN800 pipe segments are positioned on temporary supports, avoiding contact with the ground for the entire duration of the mounting operation until they are launched into the ditch. Execution of pipeworks is done through electrical welding, manually or automatically. For productivity increase and quality assurance of welding, Habau PPS pipeline systems uses mechanized welding procedures. These procedures involve multiple stages. First, the pipes that must be welded are aligned using an internal clamp. The execution of the root pass is done semi-automatically by 2 welders using STT technology, surface tension transfer Lincoln Electric, in a vertically descending way in a closed habitat. STT is a welding process with controlled transfer, specially designed for making the first welding layers of the pipes, which allows the welding of pipe with improved productivity, ease of operation, controlled heat input, very good penetration with complete edge fusion and excellent bead control. The penetration is complete without flaws, made with a cord with a thickness of 4 to 4.5 mm. It is a much more productive process than welding by any other process, being more tolerant to joint geometry and ovality. The internal clamp is removed immediately after performing this operation. The welding tent for the second operation is positioned. The joining with the root pass, which has already been executed, a process that can be accomplished by mounting the rack rail for mechanized filling in an area with protective gas. Performing the mechanized filling layer is done by 2 welders, each supervising the mechanized pipe welding equipment. The filling and front layers, which are subsequently executed, is using welding process with flux cord wires, pipeliner G60ME or outer shield OS81NI1 HSR and protective gas, and uses magistral pipes, dedicated welding equipment. The third welding machine with flux cord wire in a protective gas environment is positioned where the front welding is performed. This operation is performed by 2 welders, supervising the mechanized pipe welding equipment. The flux cord wires are specially designed for filling and front layers when welding pipes, this ensuring a very good performance and high quality. The penetration is good, welding is flawless, making the welding perfect. All the main line joints on the ground will be sandblasted and covered with heat shrink sleeves. The trenches will be executed after insulating the joints, while the soil is being excavated directly along the pipe string central line. When setting the depth, there is taken into account the fact that the pipe installation in the final position will be at least 1 meter from the ground surface up to the top of the pipe. That is why the excavation will be 2 meters deep, the width of the trench being of 2.2 meters. The launching of the pipe into the trench is carried out using mechanized launchers with lifting straps whose surfaces are smooth, preventing damage to the pipe insulation. To make sure that the elasticity of the pipe material is not exceeded during the launch of the pipeline, the launchers are placed at maximum 20 meters from each other and the pipe thread is not lifted during the process more than 1 meter from the ground. In between the lower tronçons, manual welding is performed for connection. The pipe padding operation follows immediately after it is launched into the trench to stabilize it. The process is executed manually and mechanically, using the excavated soil, avoiding strong bodies that can damage the insulation. The fillings are executed manually, in successive layers of 10-15 cm to 30 cm until the upper pipe is covered. Each layer is compacted separately. The rest of the filling will be mechanized in layers of 20 to 30 cm, also well compacted. After the trench is filled with the soil resulted from the digging, the vegetation layer is restored, with the land deposited separately after scraping, the surface returning to the initial state. The pipeline thread thus assembled, executed according to the entire set of operations, is to achieve the connection of the Bibeș station with that of Jupa. The completion date of the pipeline segment from the second and third lots is estimated for March 2020. The Jupa compressor station is connected to the DN800 Jupa Hungary and DN800 Jupa Bibești pipelines. It aims to increase gas pressure to compensate pressure losses through friction occurring during the transport process. Habau PPS Pipeline Systems builds the station to be equipped with PIG reception and launching facilities, manifold in-out gas measuring installations, 3 centrifugal compressors driven by gas turbines and turbo compressors related utilities. The station will also benefit from auxiliary systems: depressurization, leakage, combustible gas, instrument air, nitrogen, clean oil, waste oil, diesel fuel, industrial water, firefighting water. The estimated completion date of the construction works is May 2019. After entering the station, the gas will be subjected to a filtration, compression, cooling and measurement process and will be sent back to the BRUA main pipeline, whose transport capacity in the direction of Hungary will be 4.4 billion cubic meters per year, and towards Bulgaria 1.5 billion cubic meters per year of natural gas. BRUA represents the diversification of the natural gas supply sources of the European countries, meanwhile securing Romania's supply through access to a new source of gas.